Welcome back to another operating systems video. Today we're going to look at one of the last pieces that we need before we really kick things off and jump our operating system into protected mode, and that is how do we read from the disk using the BIOS. We don't want to abandon the BIOS and move into protected mode before we can do this, because we'll need to read our kernel from the disk. So let's take a look at the code that we have. I'll start with my very simple disk read main class here. Basically, we're just passing some arguments here that we might need to change, and we have a separate disk read function that handles the main part of the work. The first argument is AL, which is the number of sectors to read. Right now we're just reading one, and it's going to start after the bootloader. In other words, this first 512 bytes is the first sector. We'll start with the first sector after that and only read one. And you'll see right here that that sector is 512 bytes of the character F. So that's going to be also how we test, did we actually read the disk, and output that data. The next thing is, we set up where we want to load everything into memory. In this case, we set BX to 0 and then move it into ES because we cannot set ES directly. That's our segment register, 0. Second, we just set BX to 0x9000. Since ES is 0, the segment doesn't get added to anything. It's very simple. Our actual memory address is really 0x9000. Now, if something were to be in ES, for example, if 0x1 was in ES, you would shift it left 4 bits, and then you would add that to BX. So if 0x1 was in ES, it would actually be memory location 0x10, and then it would add that to BX, so the final address would be 0x9010. But we're not going to worry about that. We're just going to throw it right in there at 0x9000. So that's your setup. Then we call disk read, and we're going to print this string that just says reading from 0x9000. And then we're actually going to go to 0x9000 and move that character in memory to AL to be printed and see if it's the right character. So before we get into the nitty-gritty of how this disk read function works, let's just take a look at what this looks like when we run it. So I'll show you the make file first. It's very simple. It's what we've been doing the whole time. It's just convenience at this point. We assemble and then we run. So I'll say make, and here we go. Reading from 0x9000. F. You can see the F character there. If you don't believe me, I will change it to a different character. Z. Make, and there it is. So we really know it's reading from the disk, or in this case from our bin file, which is standing in as the disk to QEMU. Next we'll go into what that function is and how it works. So I've been reorganizing the repository just a little bit. Today's lesson is in 06 read disk. Everything is contained in this folder except the reusable code that we wrote for today, which you will find in a new lib folder. So in the OS directory we'll go to lib, and you'll see some of the reusable things: print hex, print string, GDT, we don't need that yet, we'll need it soon, and disk read. So we're going to talk about disk read right now. Dependencies, print string.asm, so you'll just have to make sure you include that before you include this because it uses that code. Or maybe after would be fine too, I'm not sure, try it. It also lists the arguments that we just set up in the other file, AL, DL, and the memory locations. And we jump right in, and this is basically just setting everything up based on, the documentation, Ralph's interrupt list or wherever you get it from. AH, of course, is just telling you which function, disk read. We set up the sector. 0x1 is the boot sector, 0x2 is the first available for data, and in our other one we filled it with F characters. The cylinder, don't worry about that. That has to do with the actual physical structure of disks and floppies and things. We'll just go for the 0x0, the default. DL is something that we passed in as well, and it may be set by QEMU, I'm not sure. 0 is floppy, 1's floppy 2, 0x80 is hard disk drive, 0x81's hard disk drive 2, and the head number is 0. So basically we're just passing in all of the physical characteristics of this disk and where we would like to read from. And nothing too crazy about that. We call it int 0x13 disk read, and it goes at it. Now, the carry bit will be set if there's a disk error. So we do a jump if carry bit set to .disk error. Assuming we did okay there, we're going to compare AL, the number of sectors we were supposed to read, to 1, and then if these two are not equal, we'll jump to sector underscore error. I just want to note, I may have forgotten something here. We may want to push AL at the beginning of this function and then pop it here to make sure that it doesn't get changed when we call int 0x13, but I'm not going to do it right now. And then if all went well, we'll return. So down here, our error handling, Both are very simple. We're just going to move our disk error string into bx and call print string, or the same thing for sector error, just move that sector error string in and print it. And down here you'll see them defined, error reading disk, wrong number of sectors. And that's about it for disk read. Once again, we'll run it and check it out. Really cool. For some reason it took me forever to figure this out, but I have at least one working version here, so rip it off and make it work for you. Thank you again for your attention. See you next time. Hold the phone, you're in for a bonus round. I actually just realized the bug in my code. Before we were comparing AL with 1. That's hard coding the number of sectors we requested. Like I said, we did need to push something. You push AX because AL contains the number of sectors we need to read. Then after we perform the disk read, we pop it into BX, and then we can compare AL and BL. Then jump if you get a sector error. I couldn't figure out why if I read more than one sector, I was getting an error. This is why. So if we go back to our original code, we can update our number of sectors to 2, and it still works. We get our F. However, I added an extra 512 bytes of X. What if we wanted to read an X out of memory instead? Since we did just do 2 sectors, the F sector and the X sector, we can do that. So how do we do it? I will change the address to 9200. 512 bytes to hex is 0x200, so we just add those two numbers together to get to the end of the F sector and the beginning of the X sector, and then we run it again, and would you look at that, you get an X. So there's your bonus. See you next time.